Hello everyone. So yesterday we discussed about set, and in set we are doing three set. We found some class test exception and we found some class test exception, right? There I explained you about comparable little bit and implemented a comparable which is not the right implementation. Today we'll continue from there and we will see what else I can finish today. My target is to go with map, also to go with comparable and comparator. So what is comparable? Comparable and comparator are the two interfaces which helps you to uh, sort uh, sort an non-primitive data type or a class. It basically comparable basically stores all the objects in a natural order, and comparator it allows you to sort. Both of them allows you to sort. In comparable, only you can have one kind of functionality, one kind of logic for sorting, but in comparator, it gives you an option to have multiple sorting algorithm for an object, right? So let's go ahead and see. Before that, let me send my screen. So this is what exception we are getting yesterday, and I have yesterday I made this thing. Let me go and run this and see the output which you got yesterday. Will be getting the same output, right? Same output we got, right? 82, 83, 84, 81. But if you see, it is not sorted, right? It is not sorted. So what I will do here now, I will first tell you what is the contract of comparable uh, implementation of this compare to method. See this compare to method, if you see at the param or the object to be compared, this is the param. And the return type is a negative integer 0 or positive integer as this object is less than, equal to, or greater than. If it is negative integer, it is less than. If it is 0, then it is equal to. If it is positive, it is greater than. That means if O object is lost less than this object, you have to return negative. If it is greater than, then you have to return a positive integer. If it is equal, then you have to return a 0. So that's how it is, right? So let's go and see what we have done here. The implementation we have done, it is ternary operator, it is returning two values 0 and 1, which is basically wrong. I can do it in another way. What I can do, I can say 1 and minus 1, right? But again, there is no concept of 0 here. I can't return anything if the object is equal to, right? So let me run it. So see, here it is showing it in a sorted array, right? 81, 84, 83, 82. From this, I see, I have two paths here. One is 81 and the other is 83. 83 is according to my certificate and 81 is my original path. During our time, parents, they used to give a particular, uh, while admission, whatever they come to their mind, they put it, that time path certificates were not that much mandatory. Anyway, so let's go ahead and do a proper implementation for this compare to method. So already I told you now what is the proper implementation of this method, right? So first we'll do if this, we'll take it from here, right? If this is less than this get ID, check this. See, again, we are checking less than. So this is string, right? So we have to parse it. And it's a bigger string, so I cannot parse it. So we'll parse it, right? We'll do parse long, and then only it is possible to compare it. as long as dot get it, right? So this is what now return what it is going to return minus 1. Similarly, if it is greater than, we will return. If it is greater than, we will return 1. If it is equal to, by default, if it is not less than, if it is not greater than, definitely it will be equal to, right? So directly I'm returning 0 without checking any condition. So return 0. So let's see. Let me run it now. Right. So it is. Oh, I did something wrong. Did I 832984832843 all the numbers are the same. It is reverse. So I might have done something wrong. Let's see if it is less than. Oh, this object is less than this. Return 0, less than this, greater than this. So see, this is how it works, right? So let's say I will make two IDs same. This 84 also will make 81. Right? So now let's see how it happens. What it gives the output if it is 0. See, 81, 82, 83, because 0 is duplicate. If ID is equal to it, so that is the reason it is not storing it, right? If I make it again 80, let's say I will make it 86, right? So now my wife's birth year is 86. So came 86, right? This is how this set, and you know the comparable. I'll show you the comparator implementation also now in this session. First, I'll show you the one comparator implementation. Or no, first we'll finish the map. We'll finish the map, and then I'll go and show you the comparator implementation. Any concern, any query, any doubt, you can always ask me over the comment. You can send me mail. You can message me on LinkedIn. I will be able to clarify you. And if you want to have a live session, one-to-one session with me, always you can message me. I will schedule a Google Meet or Zoom meeting. We can always have one-to-one session. So here we'll create main map. Like main set we created. Similarly, main map we will create one main class and we'll practice. We'll show you there what is how does a map works, right? Method. Now I'll copy the same classes from here. No, creating again it takes some time. So already we have created employee classes and objects, right? So I get it here. So here tree set will not be there. Here we'll have map. So let me first create a hash map. Before showing this, sorry, after showing this, I'll go and show the theory part of it on internet, right? Here generic is there. I will show you the generic part also. See inside you have already seen the generic and list also you have already seen the generic. And after completing this map and comparable comparator, I will go through the generic section. I will tell you what exactly is generic. If this would be a mindset class, I would have given a very good positive knowledge about mind. From last 11 years, I'm struggling, but I'm still doing my work. Though I don't have a job, I'm applying for it, but still I'm doing my work. See, Since I don't have many job, I'm idle. I'm utilizing my mind, my work in a positive way. Still, there are some people those who don't like me to, you know, upload this video. One person said me, Satya, why you are uploading this video? What is the required of this? I have so many videos are there in Java. Yeah, I said, I know so many videos are there in Java. It is, I'm utilizing my time in a better way. I'm utilizing my time in better way. So that is how positive mindset, right? You utilize your time in a positive way, better way. See, HashMap has one called put method where you can store your object to the map. So the first element of the hash map is key and second element is the object, the object which you are going to store. So here in this key, what I will do, I will store this ID as the key, right? For first employee object, I did the same thing in line number 19. I'll copy that and we'll go to the line number 28. There also I will do the same thing. And then I'll go to the line number 36. There also I will do the same thing. Then I will go to line number 44. There also I will do the same thing. Right? So now you see we did what we did. We are able to store it into the hash map. Now storing is not only the matter how you're going to retrieve, right? So how you're going to retrieve? How we're going to retrieve, that is another question. See, there is something called iterate our map. This is how we iterate our a map. You know, when you iterate our a map, or it map will give you a entry object, an entry object, and that entry object is basically will hold a key and type value type, and that key value is basically your the result, right? So see it here. So it will Java util map. So there is no import. That's why it is showing here. See, this key is basically a string value, right? And this is basically employee. Now generic, I will just remove the generic part of it, and I will just remove the generic part of it. Without using generic, I will show you and then I will modify it to generic. Commitment in life, in life, commitment, dedication is everywhere. And if you are committed, if you are dedicated to the things, you will be able to, you know, do, you will be able to do your thing, right? So that's how the life. Okay, so this for loop is basically, this for loop is basically you need to use generic. It will be little bit critical before going to for loop. This for loop, I will tell you how to access it through normally, right? Using fetching this thing. Hold on. So this how you do map equal to you get a entry map, right? You get your entry map. When you get a entry map, this entry object you have to iterate to get your to get your one second. You got your entry object, right? And then entry object you need to iterate. Now this entry object will give you dot not this one. Hold on. It is not this one. As map dot get dot compute content entry set equals for each consumer action, avoid hash map, get, is empty, is reset, merge, notify, put or remove, replace, to string value, wait, next, hash map, map entry. Entry set. Okay, this entry set will give you a set. That's how you go. It is actually a downcasted here, that's why it is giving error. Here, set, entry, set. Right? So downcast is not required. So this entry set will give you now what you can do. So what happened? This is a for loop which is used for this entry set, right? Now entry set has dot iterator like I have what I said earlier. The same way we're going with here, like in main set. So now if I run this program, what it will give me? Let's see. Okay, okay, I'm not printing anything, right? Let me print that object itself. Why synchronized? See, we're getting the object 81, 82, 83, 86, right? This is how the entry set you have here, right? This entry set goes this way. Entry set give you basically when you do hasmap dot entry set, you get a set, and this set is we holding your object, the whole object, right? So this is how you can iterate. This this is the key, and this is the value. This entry set will give you the key, right? So what you can do here, you can always downcast it to employee like this. Since you know what type of object is, you can always downcast it to employee. And then, okay, class cannot, what is that? I did something wrong here. See, it is saying class util cannot class collection employee. The Java util has not Java util loader bootstrap collection employees on that model. So it is, okay. So to understand what class it is giving, we can do a thing here. Iterator that next what it is giving, what we can do, get dot class dot get name to check what type of object you're getting. Always you can do this way if you're confused. This is what I'm going to tell you. It is always a debug approach of your application, how you can see we're getting a hash map dot. So basically the set entry set has a map hash map, right? And this hash map node. So let's see what we can get from this object. It is hash map node. Hmm. So this will give us a, I think, map entry. Upload is what? It's a long time. Yes. So we are getting this now. Map entry. So in map entry, you do get key, right? To see what you are getting. If it is proper, it will show give you the key. See, it is giving only the key. So what happens? This entry set dot iterator has next set. It will give you, this entry set will give you a map entry, and this map entry will hold the key value file. Now I'm using this key, and if I print this below, that will be the object, that will be the value, right? Key. I can show you how it is going to print. See, employee, and you are getting the whole employee object. So this how you have to retrieve from the this how you have to retrieve from the employee object. And if you want to do it in one shot, one go, you can follow the first initial for loop which I shown. So here it is like this. What you do? Iterate over map. Directly you get this. But here the good part is your key type. What is your key? Key is string, right? You use generic here. Value is employee, right? Directly you used this. Now it should be asking. It is still showing error. What error it is? The hash map cannot be resolved. Why hash map cannot be resolved? Okay, capital. So this is how, right? And it is what again error we are seeing some compilation error. Type message can convert from the element of type object to the map entry string employee. I think it is this for loop is actually for this for each loop is actually we can use for it, but it is showing some error. So fine, leave it. See the fast approach which I have shown, go with that approach. And if you can fix it, this for loop, go and look and fix this for loop, try it with this, right? This will help you how to store this thing. So you are able to see how to set into a map and how to retrieve from the map, right? So let me go and show you, let me go and show you this thing from, I'll show you now the map hierarchy. Java map. So this is our map hierarchy. We'll go to an image and I will explain you from there. Okay. See, in this current world called, according to Hindu Dharma or Hindu religion, this is the age of Kali Yuga. You know, how much you are provoked by Kali, the person who would always tell lies, the person who always tell dirty things, they are always provoked by Kali. So it depends on you how you want to live this life. People go to temple, but they still then, what they do. They tell so much of lies, so many dirty things. So either you go to temple or you don't go to temple. What matter is what you're feeding to your mind. Your mind is very important, right? So always be positive, be confident, follow your commitments towards yourself and towards other or given to other. Be committed, be dedicated. It's almost so many years. Still, I have some issues, but I'm committed. Similarly, you all need to be committed to your studies, your job, your family life, your everything. You see your collection. Some collection where it is coming. Okay, here we don't have map. This diagram is not having map. This fellow is not having map. Yes. Yeah. So see here. If you see map is going to sorted map, navigable map, tree map. So in tree map, all the keys will be sorted, right? In key map, whatever you in tree map, whatever value you sort, it will whatever value stored in the key map, it will sort the keys and store the values inside it. What is hash map? That's what we did now. And linked hash map follows the linked list concept. Hash table is a synchronized one. It is thread safe. When I'm talking about thread, I will talk about what is thread safe synchronized, so not worry about that. Now, see, I have shown you hash map. Tree map is also same thing. I will show you that also. Right. Go to Eclipse. See here we are getting 81, 82, 83, 86 because we have implemented the comparable interface. And we have implemented equals method, we have implemented hash methods, and accordingly it is working. So see, that time we got this error in set. Now let's comment this compare to method and see what it is doing in case of map. So let's go to main map, run it and see. See, it is working. You know, in set also it should work without implementing comparable. I don't know why tree set has given that issue. Maybe because of its need. And we'll see. We'll convert this map to tree map and see if it is throwing it here because tree always what it does it stores in natural order, right? And when I'm going with tree map here, what will be it? It is again string we're storing into it, so it should not throw any issue. See, in tree map also it is not throwing any issue, right? Even if the comparable or comparator is not implemented, right? Tree map it is giving the sorted 1 to 1, 82, 83, 86. The keys are sorted. To go to hash map, also it is showing the same way, right? So there is no issue. And when I was talking about generic here, also you can add generic. So what we are doing, first one is the key, then object value. So this is how the generic get stored, or this is how the generic implements in case of your map. This is how it is your hash map, or how you go with hash map, right? This is the things which happens. See, I will tell you one more thing. If the hard work you are doing for your programming or coding or at company or at college for writing codes, it is your hard work, your dedication, and someone should not force you or someone should not eat your dedication or hard work. What you do. That is for yourself, yours, right? So that's how it is. So let's go to the next part of this. We have to implement the comparator, right? So I will see in comparable we have implemented the in comparable we have implemented sorting based on the IDs. Here what I will do here I will implement sorting based on the age, right? We'll go to class comparator age comparator will do it implements so this is how right this showing error because we have to override add on implemented method that is we have to override this method right compared to here also it has the contract. I have opened yesterday this comparator class. Let's go to the compare to method. Param 01, the first object to be compared. 02, the second object to be compared. a negative integer 0 and positive as the first argument is less than, equal to, or greater than the second, right? So if first argument is less than the second argument, then negative. If the first argument is equal to second argument, then 0. If the first argument is greater than second argument, then positive integer. This is the way it is implemented in comparable. But comparable is taking only one argument and comparing with this argument. So now how to let's implement it. And here I will show one more way of generic doing, that I will show you here. But first let's implement. But I will explain about in detail about generic later, not now. Here, uh, you know, here let's this object is employee, and this object is it. What it is saying? It will say you add on implement method. You know why? The reason behind that you cannot change the parameters while overriding. It should be the same parameters. Then only it will call us. Then only you will be able to override the method. If you change the parameter, it will not be overridden. It will be overloaded method, right? That's what in one of the previous session I was talking about in very beginning, overloading and overriding. So what we have to do? We have to downcast it here, right? Inside it, we have to downcast employee one will let emp, and then here we'll downcast this object employee, and while sending this object, we should be very alert that we are sending the right object. Otherwise, what will happen? It will show class cast exception again. Now here we are checking with age, right? I'll just copy paste that from the employee the conditions if else because it is easier for me and it will be faster, right? This if else conditional copy paste while implementing just need to verify. So we'll make it int. Integer. It will be parse int, right? If it is integer, it is parse int. Since we have already downcast, we have done downcast. What we will do here, parse int, we will do emp dot get else, right? And here we will do empp dot get else, right? Emp dot get else, empp dot get else. So this is how it is. Now it is saying if first object is less than second object, then -1. It should be -1. If first object is greater than second object, it is positive, and otherwise 0. Now let's go to main method. See, while running this, if I want to use this thing, what I have to do? I have to use where is that main set? Let's go to main set. Yeah. So whatever you are seeing, this secretary is showing you based on this thing, based on sorting based on age. Here, let me run this in main set. sorry, based on ID because it is using the comparable, right? It is using comparable and it is showing based on the IDs. Now we'll have another that will show based on the age. So how you will do that? Collection, collections, right? I told you one utility class. Collections dot sort, right? In sort, here you can pass what is that tree set, right? And here you can pass as comparator dot, right? What it is showing, it is giving some error. The method sort list comparator super T in the collection sort is not applicable for the tree set employee or class age comparator. Okay, it is not applicable for these, but then we'll go for to the array list. One second. It's not applicable. It is, I will show you. Hold on. Okay. With the natural order setting, if you, okay. One second, hold on. Set, shuffle, list, swap, synchronize. Hmm. Sort is basically saying list. You know, that is list T. It is taking list. Sort is taking list. Collection dot sort method is taking list. Collection dot what else method is there? Shuffle, singleton. Hmm. Hmm. Okay, fine. So we see this is S comparator. We will do it with the array list. One of the array list will take. And I think over here we have the same, right? Uh, same set of implementation. Here also we have the same set of implementation, right? So we're adding it to a vector. Vector is a list again, right? Let me run it. What all we are getting to, we'll comment all other code and we'll see all of this code. Set implicit department, array list, employee list dot admin p. Okay, let me run it and we'll comment most of the code. Only we'll see what all we expected to stack, linked list, and this. Okay, so from linked list to stack, we will comment it out. Yeah, it is here, right? You see, this is how it is, right? Now we have added this employee 81, 81, 81 three times and 82 one time, and we are trying to print it, right? So see what it is doing now. What it is printing. It is printing 81, 81, 81, then 82, 82, right? It is printing in that fashion, right? If I remove this, it will print 81 three time and 81, 82 two time. You know, because the comparable, this is sorted based on the comparable implementation. Now, before printing, what we will do, we will use that this here and this here we will use employee list collection dot sort, right? We will use this. Why it is again added. I don't know today wherever whatever I'm using it is giving not a clue for the argument array list employee and class age completed. Okay, is it getting trouble for this? Okay. The method sort list a comparator property in the type collection is not applicable for the employee argument array list class age completed. Sort method is like that. So sort method is taking a list, right? Sort method is taking a list along with it is taking comparator. Maybe I think maybe in the latest edition of Java they have you know a generic what I was talking, right? They might have added that. That is might be the another reason. So let me implement it in a generic way, right? Now we use that. So when you implement it in a generic way, downcast is not required. It will take automatically, right? And so I'm going to override this method. See, I will just before deleting, I will show you what is the difference. See, when I have not written generic, overridden methods are object object. Now I added generic employee here. That means this compare to comparator is going to use employee class to sort this, this thing. So I've used employee here. Override this method. See? So here I will make it EMP so that this error will go. Employee 2 will be EMP. So this is so simple, directly you'll get employee object, you don't need to downcast it. But again, all the generic are during compile time, and if you're using generic, it will be for compile time, right? Let's go to the main array list. In main array, still the same error. I why this error is same? Why this error is same? Argument list, array list employee, this comparator super T method in the type collection is not applicable for arguments array list, employee, and as comparator. Okay, so let's see one example of comparator. Here, what it is doing. A little bit of code, so that's how this thing. So let's see what it is doing. If there is no implemented here, let's see. Comparator implementing the Java comparator. Okay, the stack overflow will show you the exception and this. See, this is how we have done implementation and while using, you know, okay, this is giving some exceptions. What has implemented it is showing some error. We'll go directly to the one example. Yes, comparator and comparable in Java. This one was given one example. This is setting up the example class player. Is taken this constructor data status. Is void main string dot add. Is using list player put item same like as and as expected the result is sort list T in the type of collection is not applicable for the argument I list player, right? This is this sort will use comparable collection dot sort will use comparable which is for default setting. Now implements comparable and this is how it happens, right? That's what I have. We also have did in the this thing compare to implementation. Here is saying integer.compare. He is directly invoking the integer.compare method and passing that. We can also do the same thing. It's a clever way of doing here implementing compare to method because each class, each wrapper class, they have their own compare implementation. That's how by default JVM will invoke when you compare integer or you will compare a long or any primitive data type, right? So coming to comparator, in comparator creating a comparator. See first what it is doing, it is if you see player ranking comparator and comparator player, right? It is the same way what it is we have done. So similarly, we can create comparator to use get age attribute. That is what I have done age attribute. Like, see coincidence. I did age and here it is age. Comparator in action. Collection dot site, football team and player team. Using this application, you can override the natural order of the player comparator. This is how it should work. That is how I have implemented. That is how I have implemented, and that is how it should work. But my Eclipse is giving some error. I don't know why Eclipse is giving that error. We need to see why Eclipse is giving that error. I don't know. We need to see. Here you see player is comparator same this. Okay, so it might the error is understood. One more thing. I missed one more line. Is that it is? Let's see. Comparator, and I think we need to pass this guy here. Yeah, some line might have missed. Yes, I missed. It is my bad. I missed the right way of implementation. Sort calculator list as comparator. It happens. There is no. It's been long time. I don't have. I'm not doing that coding as much of. So see, 81, 82. So see, again, this list, they follow the insertion order. So what I will do, I will make first one 82 and last one 81, right? And what I will do here, I'm printing only ID. I will print age also, so that you will be able to identify if it is actually sorting. Okay, so see, 82, it is 80, this followed 82, 82, 82, 82, 81. These insertions order because all of them have age at same. So what we will do, we'll put on 44 and we will keep one 43, right? So let's see now how the output is coming. See, 43, 43 came first and then it came 42, right? So 81 I will make 43 and 82, 82 I will make 42. Now you see. 82 I will make 44, right? So what happened? I have given, is it following the insertion order? That also I want to show you or plus verify. See, 43 came first, right? I will insert only one here, first employee, not so many times. For 81, 81 one time, 82 one time. Yes. So if you see, I commented line number 42 and 43, 44 is on comment. That is, I'm inserting one time the 82 ID and then one time I'm inserting the 81 ID. Now I'm running it, right? No more. Now I'm running it. So just check it. 43, 44, right? 81 age is 43 and 44. Now what I will do, I will just comment out this collection dot sort and I will run it. What happened? 82 came first and then 83, right? Now I will do collection dot sort. I will remove this guy, the comparator, age comparator. See, became natural order sorting. That it's sorted based on the ID, right? Comparable and comparable we have implemented based on ID. So 81 is coming first and then 83 and then 82 and then 44. You see, first insertion is 81 and second insertion is first insertion is 82 and second insertion is 81. Now I will comment out this collection dot sort one after we go. There is no sorting algorithm is used here, right? I'm not sorting the array list. I've commented out the 50 for line number. See what the output is coming. It should come with natural insertion order. 82 first and 81 first. That is based on the ID because equals method is overriding is checking with ID. See, 82 is inserted first, right here, employed rate in 44 line number. And then 51 line number, 81 ID is inserted. That's how it is coming. Now, if I uncomment this, it will only, I'm not passing, I'm collections dot sort, I'm passing only employee list. What it will do, it will call comparable method. So when it is calling comparable method, what it does, it it will do sorting based on the ID because we are checking ID in comparable method, right? Comparable comparative method. That is ID 81 and 82. You see, in employee class, this comparative method is checking based on the ID. That's how it came, right? Now, what I will do, I will go to there. I will just add the comparator here. In comparator, what we are doing is, okay, so before that, what I will do, I will do one more thing. For 82, I will make 43. This is, right? For 82, I will make 43 to make it more clear. And for 81, I will make it 44. Now let me run it to see what it is happening. It is going to give me the same, 81 and 82. See, 81 is 44 and 82 is 43, right? So now what happened? I will add the comparator here in the sorting algorithm. Collection dot sort in line number 54, employee list, comma, age comparator. Right? I added age comparator. Now, when I run, age should be, see, it will be sorted based on the age. See, it got sorted based on age, 83, 43, 44. So this is how the comparator comparable are used for sorting collection or lists, right? So see, this is a way you can implement and set. Set always follow the natural ordering of that primitive data type. Sorting algorithm is always implemented in set uh, from the very beginning. So what happens now in set when you insert an object, you need to take care of implementation of that object's algorithm, sorting algorithm. That's how it works. So as I said, that example you are seeing there, right? So I will do it here only. Here what you can do, integer, same thing. What he has done, integer dot compare to. You can directly call integer compare, right? And you can pass here emp and empp. Right? This is what this he has implemented, right? If you go to there, he is using integer dot compare and implement. This is written, right? So you can do this implementation also. I have done my own implementation. You can do this implementation. It is showing some error. Let's see what is the method. Compare intent in the type integer is not applicable for the argument employee. Yeah, it is not applicable because it is employee. We have to pass get age, right? Because you're comparing based on the age. So now it is fine. Now you can go ahead with this implementation. Again, and you can comment out this guy. It's not required, but again it will show you error because our age is we're taking this age as a string. So what you have to do, you have to parse it. Either you go with your own implementation or you do or take the advantage of API's implementation. If you know API has implemented something like that, you can take advantage of that. This is how this person has taken the advantage of API. Right? So what is generic? Why generic came into picture? What is the benefit of generic? What is the advantage of generic? Right? What is the benefit of generic? What is the advantage of generic? Why generic came into picture? So these all points we'll discuss now. See, if you have any doubt in collection, You want a live session? I can take live session. It is free. I won't charge anything. If you're a student or if you're a professional, anyone, you are a fresher, joined a company, joined an organization, and you are facing coding in Java, you can always connect me. I will help you. Not only in Java, in Spring, Java, wherever you're facing any issue, you can always connect me. I will help you. So connect me. Message me or comment on the YouTube video section, comment section. Mail me on my mail ID, message me on LinkedIn. I will reply. Uh, because collection is a chapter which you need to practice and which you need to remember all these things. I will show you before going to generic. I will show you one more thing: the difference between has table, uh, between implementation is same. Only the difference is in their way they approach. Has table, implementation has table, has map, and your tree map. Well, we'll always go to some image, it's like PPT, it is similar to PPT, and we will see there. Where is that screenshot here? Yeah. See, here it is given. Time complexity of hash map order of 1, linked hash map order of n, tree map order of log n, right? Iterate order. In hash map, it is random. In linked hash map, it is sorted according to the either insertion or SSC. Hash map and hash table both are same. The only difference is hash table is synchronized. Null keys are allowed in hash map. Linked hash map also allowed, but tree map not allowed. If key uses natural ordering, comparator does not support comparison on null keys. So, but in case of tree map, null key is not allowed. Interface map. In case of tree map, sorted map, and navigable map are the interfaces which tree map is implementing. Synchronized, none of them is synchronized. But if you want to synchronize, you can use collection.synchronize map, and you can synchronize that. Data structure is list of buckets. If more than 8 entries in a bucket, then Java 8 will switch to balance tree from the linked list. So this is how they are storing basically the internal concept how a map stores the value. This is from different uh, person has different way of storing it. The latest version they are more efficient, more faster than the older version of Java. It is going in depth. If you remember, I explained one of the concept about hash code and hashing, right? Where it how the hash map stores it inside the and memory. See, each keys it take each keys and based on key it is going to create that the bucket. The internal storage, the uh, internal store, right? It will create a bucket and will store in bucket, right? And then buckets will have many values. The way I explained earlier in one of the video, it is the same thing, same concept goes here. Hash codes, right? If your hash code based on, if you remember A, B, C, D, X, Y, Z, I have explained how the alphabets are getting stored in different bucket. Like let's say your, I will give you the example again here now, right? That I want to store, all the student names of the class or the whole student name of the school in a single bucket, and you write their name in a sheet and store it in a single bucket. What happens? And you want to find a particular student from that bucket. It is difficult for you to search on that bucket. Who is the that student? You have to go one after the one. It is basically depends on the peak. It might be, first peak might have the same number, or maybe the last peak have the same number, right? It always go with the order of n, right? So that's how it is. But when You store it according to bucket. Let's say for A to Z, you create 26 bucket. In A bucket, all A person name. In B bucket, all B person name, starting with B, name starting with B. In C, all C person name, starting with C. So in that way, it go till Z. uh, so you have 26 bucket. Now you know you are searching the person starting name with, let's say, B. You go to B bucket, starting name with D. You go to D bucket, starting name with P. You go to P bucket, and then you search in that P list, right? The person name. So now you reduced the number of sheet you are going to search. And on the another way, also what you can do in this hashing algorithm, what it will do, it will find that P. It will go to P, and then after finding the right bucket, it will search the value from there. Let's say another hashing algorithm, right? Another hashing algorithm which we can do. Another hashing algorithm, let's say class wise equal to store. You ask according to class 1, class 2, class 3, class 4. You go to that class, and from that class you store that particular, you search that particular name, right? So these are the different searching algorithm used. So collection, what they does, in collection the objects are getting stored in memory. This is only I'm showing you a very few number of elements getting added to collections, but when we do in a real time program, records, lots of record will be stored in collection object, and when you search, this search should be faster, right? That's the way how you do search. I will explain you in better way in coming session with this map, how map actually gets stored and how it get fetched from the backend or from the memory, right? So that's how I will, how the list of buckets, whatever he has explained here, I will explain you that. These all are coming from data structure, right? When you see tree map, it is following red black tree, a kind of self-balancing binary search tree, right? Red black tree is a binary search tree. So I'll explain these also, right? So this is how requirement application, general purpose fast application. This is the how where all it is used, right? It again depends on us how and what kind of where I want to use hash map, or I want to use linked hash map, or I want to use tree map. Requirements for keys equals hash code needs to be overwritten. Equals and hash code needs to be overwritten. Comparator needs to be supplied for key implement, otherwise method order. So this is how the difference. What you can do, I will show you one more. I have an older version of a my time SCJP book. I don't know if nowadays the Oracle certified Java programmer books are available or not. If these books are available, always these books you give the core information and lots of good information. So if you go, I will show you. I have one book from my time, one PDF I have kept from my time, and that is very old. I will just show you. Yeah, right? Let's see. I have two books. One is for Kathesera, one is for SCCP certified C Java 8 programmer. Okay, complete reference, that is not great complete reference. This is what this might be the SCJP 7, yes, Kathesera, and another I have Oracle certified. Who has written this? Let me see. No, this is someone else. No, Kathesera, they have explained it in a better way. I don't think they are writing book nowadays. But anyway, I'll show you here. If I go to collection chapter, I will show you. Hold on. My system is a bit slow, little slow. What is generic and collection? Right. Okay, why chapter wise? Where is vacancy chapter wise? Why this is so slow here? Page number, what is it? Is saying generic and collection 573. So there. Okay. Hmm. I entered 573 page and I clicked on enter. But what happened? No, these paging sequence are not straightforward. So that's why is yeah. So if you go to here, right, set interface, a set cares about uniqueness. You don't allow duplicate your good friend equals method determines whether two objects are identical, in which case only one can be in this set. The three set implementation described following hash set, linked hash set, and tree set. The tree set is one of two sorted collection, the other being tree map. It uses a red black tree structure, algorithm. But you knew that and guarantees that the elements will be in ascending order according to natural order. Optionally, you can construct a tree set with constructor that lets you give the collections your own rules for what the order should be rather than relying on the ordering defined by the element class by using a comparator, right? This is what it says. If you come to map interface, it explains the same thing. you know you can easily here it gives you a table, right? If you see, it is explaining clearly how how these things happen, how how basically this map is getting, the values are getting stored in map. If you read all these, you will get more knowledge. Try to read a Java certified programmer book that will help you to learn more concepts. That will help you. How what is ordered, how it is sorted, how it gets sorted, how it happens. So here it is explaining. Here it is also explaining about comparable, right? Here it is also explaining about comparator. So if you see, this helps you. Go and read this book, right? Read this book. Find the latest one. Java, what are the latest certification going on Oracle Java certification program. That is latest certification process, latest certification book, and go through it. You will find the detailed information about it. Okay, since we have some more time, I will explain you how internally Java stores here itself. It is how Java Hasmar works. The same way other also work. See, this fellow has explained it very clearly. You can go through this. Not only this, there are many other website also you will find. It is how it is storing. Internally, Hasmap uses an array of buckets or bins. Each bucket is a linked list type or node, which is used to represent the key value pair of the Hasmap. You know, key value pair of the Hasmap. Above, you can see the structure of the node class, which is used to store key value pair of the Hasmap. This is how it create a linked list and store the key value pair. Right? The node class there has the following fields: has, key, value, nest. That's why you need to use iterator to fetch the nest value, right? It has, key, value, nest. This hash is basically what? It is the hash code of the key because it will store in a bucket. So to store in a bucket, it needs the hash code and key and value and nest. Nest is to find the nest value, right, where it is stored. The hash map is fundamentally based on hash table implementation, and its performance depends on two key parameters: initial capacities and load factor. The original Java doc of the hash table also defines these two parameters as follows. The capacity is the number of buckets in the hash table, and the initially capacity is simply the capacity at the time of hash table is created. The load factor is measure of how full the hash table is allowed to get before its capacity is automatically increased. how the basic operation put and get work in hash map, right? So what happened in hash function when it do a put, you know, during the put of hash function, the key value pair, first they calculate the hash code of the key. The hash code of the key is calculated. Then the hash code computes the integer value of the key to find a hash code. And this hash code, after getting this hash code, this hash based on this hash code, it will find a bucket and it will go to that bucket, and in that bucket, it basically stores these values. This is how it does that. It is written here, right? XOR is a bitwise operation. How it does internally, it is written here. So you can go through or you can read it. Above, we can see the static hash method of the hash map class. The idea is to have a unique hash code for each key, but the hash function could produce the same hash code for different keys, right? The idea is to have unique hash code for each key, but the hash function could produce the same hash code for different keys. That was I I explained in the previous session when I was trying to override the hash code method, right? This leads to situation known as collision. We'll see how to handle collision in the next section. So it will be a collision if two keys are same, right? So index calculation happens accordingly, right? Once hash code of key is generated, the hash map calculate an index with an array of buckets to determine where the key value pair will be stored. This done again using this AND operation. That's how it is. Once the index is calculated, the key is then stored at the index in the bucket array. However, if multiple keys end up having the same index, it causes a collision in such scenario. That's what I said, right? When the key is calculated, key is then stored at the index in the bucket array, and the value goes to that bucket. And if collision happens, what happens? In such scenario, Hasmap handles it in two ways. Chaining linking. Each bucket in the array is linked list of nodes. If a key already exists at a particular index and another key gets hashed to the same index, it gets appended to the list. That's how the value will get appended. The key will be same. That same concept comes from the hash code, right? Tree fact. If the number of nodes exceeds a certain threshold, the linked list is converted into a tree. That's how. That's how it defines. They convert the linked list into a tree because a tree in a particular node can have multiple in your values. Therefore, it is essential to have a good hash function that will distribute the key across the bucket and minimizes chances of collision. So you go and read, and you will be able to identify how hash map, how tree map, they all sort values. These are not required in going in such deep, but if you go, it is always better. Someone asks you, you can always explain them, and your funda will be clear. Nowadays, these are not that much required because frameworks and APIs are available. Lot of framework and lot of APIs are available where where it makes developer life easier to code and implement the business scenario with any kind of business requirement. So I think we will end this session today. I've explained so much at the end which may not be needed for you, but if you feel good, you can watch this what I'm talking here at the end. Till this time from last few minutes. Coming session we will start with generic. I have not started generic. The reason behind that, because if I start, I will have to stop. So we'll start generic. Tomorrow, full session will be generic. And if I find if something I missed on the map or some concept, I will explain it tomorrow. Uh, anyway, we will end this session here today. Thank you, everyone. We'll see in next session. We'll meet again in next session.